In this video, I'm going to show you how we can solve Bernoulli differential equation. A first order differential equation in the form of y prime plus p of x times y equals q of x times y to the n is a Bernoulli equation. Note that the difference between a Bernoulli equation and a normal linear first order differential equation is y to the n here. If you remember, a linear first order differential equation is an equation in this form. And if you compare this with the Bernoulli equation, you can see that in the Bernoulli equation we have this y to the n here. So the idea for solving Bernoulli equation has to be get rid of this y to the n. But how we can get rid of this y to the n here? With a simple substitution. If we suppose z to be y to the power of 1 minus n, with this substitution we can prove that the Bernoulli equation can be written as this differential equation: z prime plus 1 minus n p of x times z equals to 1 minus n q of x. Now if you look at this differential equation, you can see that this is actually a linear first order differential equation, which we know how to solve this type of differential equations. First we have to find the integrating factor, and then we can solve the question. So let me show you the first example. Our first example is y prime minus 1 over x y equals to 3 over 2 y to the power of 3. This given differential equation is a Bernoulli differential equation, which if you note here, this expression negative 1 over x is p of x, and this constant 3 over 2 is actually q of x. For solving this Bernoulli equation, we have to use this substitution. So if we use this substitution, z equals y to the power of 1 minus n, which is 3. 1 minus 3 is negative 2. So with this substitution, z equals y to the negative 2, we can convert this given differential equation to this linear first order differential equation, which means that this differential equation transforms to z prime plus 1 minus n. 1 minus n is negative 2, because 1 minus 3 is negative 2, times p of x, and p of x is negative 1 over x. Negative 2 times negative 1 over x is plus 2 over x. Don't forget to put z, equals to 1 minus n, which is negative 2, times by q of x, which is 3 over 2. If we cancel 2 with 2, it equals negative 2. So with this substitution, we converted the Bernoulli equation to a linear equation, to a simple linear first order differential equation. Now we can solve this linear first order differential equation. Now let me remind you how we solve the linear first order differential equations. In general, when we have y prime plus p of x times y equals q of x, for solving equation like this, first we find the integrating factor mu of x, which is e to the power of integral of p of x d of x. This is the first step, if you remember. In here, p of x is 2 over x. So first let's find the integrating factor. So mu of x is e to the power of integral of 2 over x dx. Integral of 2 over x is 2 ln of x, which we can write it as e to the ln of x2. If we bring the power to the coefficient 2 to the power of x, we get e to the ln of x2, and we know that e to the ln of any expression equals the same expression. So e to the ln of x2 is x to the 2. So x2 is the integrating factor. Then after we find the integrating factor, we can find y in general from this formula, 1 over mu of x times by integral of mu of x times whatever is in the right side dx plus c. This is the general way of solving a linear differential equation. So here we can find z, because we have z as the function, not y. So here z equals to 1 over mu of x, which is x2. So 1 over x squared bracket integral of, again, x2 times by q of x, which is -3 times -3 dx plus c. If we write 1 over x2 again, integral of -3x2 is -x to the 3 plus c. But note that this expression is z, but we are looking to find y, because in our original differential equation here, y is the unknown, not z. Now if we replace this z with y to the -2, we get to this y to the -2 equals to -x to the 3 plus c over x2. And so this is the solution of this Bernoulli equation. So let's review the process. For solving a Bernoulli equation, first we make this substitution. With this substitution, this equation transforms to a linear equation, and we know how to solve linear equations in general. So the only extra step that here we have compared to a linear equation is this substitution. And of course, you have to memorize this formula, because you have to know after the substitution what is the new equation. If you want to get rid of memorizing this formula, you can do the substitution explicitly, which I will show you in a moment, how from this equation you can get to this equation without memorizing this formula. But of course you have to do a little algebra. Before I show you how you can transform the Bernoulli equation to this transformed equation, note that if you like, you can write the solution here in explicit form. I mean, we can write y in terms of x, but maybe it's better here to leave it in this implicit form, because if you want to find y in terms of x, because this power 2, you have to take a square root and you have to put plus minus, which I think this form is better. So let's leave it here. But now let's back to our question. How with this substitution the Bernoulli equation transforms to this equation? Let me show you how. If you want to transform the Bernoulli equation with this substitution to this equation, first of all, note that it's better to first divide, so always divide the Bernoulli equation by y to the n in general, which in this case we have y to the 3. So before doing anything else, first divide both sides of the equation by y to the whatever power here we have. So first we divide both sides of the equation by y to the 3. If we do so, we get to this equation. Y prime over y to the 3 minus, if we divide this term by y to the 3, we have a y here. If we divide that by y to the 3, we can get 1 over, change the color here, 1 over x times y to the negative 2. Again, note that we divide this y by y to the 3. If we cancel y with y to the 3, and y to the negative 2 remains, because we get y 1 over y2, which if we bring this up, we can write it as y to the negative 2. And if we divide this by y to the 3, we get 3 over 2. Now, based on this substitution, we can replace this y to the negative 2 with z, because y to the negative 2 is z. But okay, bring back z here. But how we can get rid of this y prime over y to the 3? From this substitution, note that z prime is, if we take derivative from both sides of this equation, z prime is negative 2 y to the negative 3 y prime. And now if we look at this, and here this expression actually is y to the negative 3 y prime. If we bring y to the 3 to the numerator, it's y to the negative 3 y prime, which exactly here we have. So instead of y to the negative 3 y prime, we can replace z prime over negative 2. So now it is clear how we can get rid of this. So we replace this with z prime over negative 2. And we replace this with z, because y to the negative 2 is z. So we have minus 1 over x z equals 3 over 2. Now if you multiply both sides of this by a negative 2 to get rid of this negative 2, we have z prime plus 2 over x z equals negative 3. Now if we look at this equation here, you can see that they are the same. This is how you can transform a Bernoulli equation with this substitution to a linear first order equation. Now it's up to you. You prefer to memorize this formula, or you prefer to do this substitution explicitly. Let me show you another Bernoulli equation. Here the differential equation is x dy over dx plus 6y equals to 3x y to the power of 4 over 3. First note that because here the coefficient of y prime is not 1, it's better to first make this coefficient 1, because in a normal standard Bernoulli equation we expect to have something like y prime plus p of x y equals q of x times y to the n. Note that coefficient of y prime here is 1. So before doing anything else, let's divide both sides of this equation by x to get rid of this. So the first step is to write the differential equation in this form, y prime. I prefer to write instead of dy over dx, y prime plus 6 over x. Y equals to, don't forget we have to divide this side also by x. Then we have 3 y to the 4 over 2. Now we have a Bernoulli equation in the standard form. Note that this is p of x and this 3 is q of x. With this substitution, z equals to y to the power of 1 minus n, and note that n here is 4 over 3. So 1 minus 4 over 3, which is negative 1/3. We can convert this Bernoulli equation to a linear first order differential equation. The transformed equation is z prime plus, if you don't remember, let's take a look again at the formula, 1 minus n times p of x. And here 1 minus n is this negative 1/3. 1 minus n is negative 1/3. So you have to multiply this negative 1/3 by p of x. If you multiply negative 1/3 by 6 over x, this equals negative 2 over x. So we have negative 2 over x. Z equals to 1 minus n times q of x. 1 minus n again is negative 1/10 and q is 3, which if you cancel these you get negative 1. And now this is a linear first order differential equation. For solving this equation, first we have to find the integrating factor. The integrating factor is e to the power of integral of this, integral of negative 2 over x dx, which is e to the negative 2 ln of x, and this equals e to the ln of x to the negative 2. Finally, this is x to the negative 2. So the integrating factor is x to the negative 2. And so z equals, if you don't remember how to solve first order linear differential equation, take a look at this formula, 1 over integrating factor times by integral of integrating factor times q of x dx plus c. So here z equals to 1 over mu of x, which is x to the negative 2, times by integral of integrating factor x to the negative 2 times by q of x, which is negative 1 dx plus c. First of all, note that 1 over x to the negative 2 is actually x to the 2. If you bring this up, make the power positive, so this equals x2. Integral of negative 1 over x2, note that x to the negative 2 means 1 over x2. Integral of negative 1 over x2 with the power rule from integral is 1 over x. So this integral is 1 over x plus c. If you don't remember how to calculate that integral, note that negative 1 over x2 dx, or negative x to the negative 2 dx, is negative x to the, add 1 to the power negative 1 over negative 1. This goes with this, and this is 1 over x. With the power rule, you can calculate that integral. Okay. Now let's continue solving our equation. Note that z was y to the negative 1 over 3. So we have y to the negative 1 over 3 equals to this. And if you multiply this x2 in the bracket, you can write your answer as x plus cx2. Note that x2 times 1 over x is x, and x2 times c is cx2. And finally, if you want to write the solution explicitly, I mean if you want to write y as a function of x explicitly, you have to try to get rid of this negative 1 term. How we can get rid of the power negative 1/3? If we raise both sides of this equation to the power of -3, the inverse of this, like this, -3 multiplies by this and they cancel each other, so y remains. So by raising both sides of this equation to the power of -3, y equals to x plus cx2 to the power of -3, which if you prefer you can write it this form as well. And this is the solution of this Bernoulli equation. Now let me show you how with this substitution this Bernoulli equation transforms to this equation. Again, as I mentioned in the previous example, before doing anything else, first divide both sides of this equation by y to the power of n, which in this case is y to the 4/3. So we divide both sides of this equation by y to the power of 4/3. Then, if we divide both sides by y to the 4/3, we have y prime over y to the 4/3 plus 6/x. If we divide this y by y to the 4/3, note that power here is 1. If we subtract this from that, y to the 1 minus 4/3 is y to the -1/3. So 6/x y to the -1/3 equals to 3. But note that here, because z equals this, so z prime, if we take derivative from both sides of this substitution, z prime equals to -1/3 y to the, if we subtract 1 from this power, -1/3 minus 1 is -4/3 y prime. Now again look at this and look at here. They are the same. So y prime over y to the 4/3 is actually z prime times by -3. You have to move this to the other side. You have to multiply by -3. So we can replace this with -3 z prime plus 6/x z. Note that y to the -1/3 is exactly z, is the substitution, equals 3. Now if we divide both sides of this by -3, we have z prime minus 2/x z equals -1. Compare this with this equation. As you can see, they are the same. Again, it's completely up to you. If you prefer to do the substitution explicitly and transform the equation to a linear equation, you can do this. Or, if you prefer to do it faster, memorize this. I hope by watching this video you have learned how to solve the Bernoulli equations. If you like this video, please subscribe to my channel.